Hello everyone, welcome to chemistry class. We have been discussing the chapter number 4, the structure of the atom, and this is the part 2 of this present chapter video series. In the last video we had discussed about how the atom was discovered, the earlier views regarding the presence or absence of atom in nature. So first of all, atom was predicted that it exists by Cathode. He was an Indian philosopher. He predicted this, that matter contains small particles called as atoms, and then he gave the term Parmanus for the atoms. Next we had discussed the theories of Democritus and Leucippus, which was actually proved wrong later on. What they said was that atoms are indivisible, but later on came, after that thousands of years passed away, none of the people paid attention to the views of Cathode and Leucippus, and atomic theory was proposed by John Dalton. He was an English chemist and he proposed the atomic theory. The various points, various features of this theory we had discussed in the previous video. Then the theory was also saying, Dalton's theory was also saying that atoms are indivisible. But later on it was proved that atoms can be divided into small particles called as the subatomic particles. And basically there are three types of the subatomic or the fundamental particles inside the particular atom. What are those three particles are? First one is electrons, second is protons, and the third one is neutrons. So now we will be studying about these three subatomic particles, how they were discovered and what are their characteristics. In today's video we will be learning about the electrons. So let us come to the topic of electrons. The electrons were discovered in a particular experiment called as a cathode ray tube experiment. Here you can see a diagram here. This is what is called as a cathode ray tube, and in this particular experiment, when electric supply was turned on, cathode rays were discovered, or ultimately we can say electrons were discovered. Who discovered the electron was Sir J.J. Thomson. Sir J.J. Thomson discovered electrons for the first time. How he did so, let us have a detailed discussion now of what his experiment was. So under ordinary condition, in normal situations, what is happening? Gases, different gases, they are generally bad conductors of electricity. They do not easily conduct electricity. But sometimes a gas can conduct electricity. Normally they are bad conductors, but when certain situations are provided, there may be a chance that a gas will also supply electric current. What are the two conditions that are given? First is the pressure of the gas must be very, very low. Second thing, the voltage applied should be very high. So these two conditions, if they are provided, then we can say that a gas can also conduct electricity, which is not its normal behavior, but in these conditions it can do. So when these two conditions are achieved, then we can say we have obtained what is called as discharge tube. Here you can see the diagram also. This is what is called as a discharge tube, and in this only cathode ray will be observed. This particular setup is a discharge tube, also we can say cathode ray tube. So the discharge tube is what? The definition is given. It is a long glass tube at the two ends of which are sealed two metal plates. Let us see in the diagram. Here it is. So it is a long tube like structure. You can see one side here you have the exhaust pump. This is just to regulate the pressure. Exhaust pump is doing what? It is maintaining the pressure only. Inside this you can see two metal rods are there. I have put in boxes. Two metal rods are there, and these metal rods are working as electrodes. Electrodes क्या करते हैं? They are participating in this reaction for the conducting of the electric current. So these are two metal electrodes, the metal plates. These metal plates are connected to the wires. Here you can see all around wire is there, and in between here a battery is put up. Here you can see now, here it is written high voltage source, so that is the battery, and it is connected to the wire. All through wires are there, and ultimately the wires are joined to these two metal plates. One of the side you can see on the left hand side, the metal plate is acting as the negative terminal. Here negative terminal is there. Because of the negative charge, it is called as cathode. The another one on the right side of this diagram, you can see it is positive charge. The positive charge metal rod is working as anode. So these are the two metal electrode. One is cathode, one is anode. Both are connected to the electric wire. Wire is ultimately connected to the battery. So same thing, only in the reading also is there. So that is, electrodes are there. One connected to the negative is cathode, another one connected to the positive terminal of the battery is called anode. Also we have one exhaust pump, which is for lowering the pressure of the gas inside the discharge tube jet. That already I shown in the diagram. Here exhaust pump is there to regulate or maintain the pressure. Now let us have a discussion how the experiment has been done. First of all, we have seen the setup of the experiment. What are the various substances, things, whatever are used here, we have seen. Now when we will turn on the electric supply from this battery, the electric current will start flowing, and as the current is flowing here, that is when a high voltage is applied, then what is happening at that time, only the end which is opposite to the cathode, the end of the tube which is opposite the cathode, it will start glowing. Why does it start glowing? It starts glowing because some invisible rays are starting from the cathode and falling on the opposite wall of the tube. Where they are falling, that side only is glowing. So this process of glowing of the tube, the cathode ray tube or discharge tube, is glowing at one of the side. That is, this process is called as fluorescence, and fluorescence is observed in this cathode ray tubes because the rays are emitted from the cathode. From the cathode, the rays are moving forward and they are striking the another surface. You can see on the right I am making. So this side, what is happening, let me change the color. So on the right side here, you can see I have highlighted with blue color. This side you will see a light is glowing there. That is, on this corner, on this end of the tube, fluorescence is there. And because this fluorescence or this glowing of the light is observed on this side, that means what is happening, actually the light rays or some particles are coming from the left hand side of the tube, and basically actually from where they are coming, they are released from this metal plate, the metal plate which is acting as the cathode. From the cathode, some particles are coming and they are striking the other surface. Because the particles are emitted from the cathode, they are given a particular name. What is it? These rays were named as cathode rays. The rays, whatever rays are coming here, all of these are called as cathode rays. And also that is why this experiment is also called as cathode ray tube. So this is how cathode rays were produced. What are the conditions? Again I repeat, that is, high voltage electric supply is there, that is one. And second condition is the pressure inside the tube is relatively very high pressure is there. So this is the experiment, that is of the cathode rays. So actually what happened here, these cathode rays which are coming outside here, what are these cathode rays actually? So when the electric current is moving, it is moving forward, it comes to this metal rod में जैसे इलेक्ट्रिक करंट आता है, at that moment only it will start producing these cathode rays. What is cathode rays actually are? These cathode rays are only the electrons. I have made sign E minus. E minus means electrons only. So in a symbol manner we can write this. So that is, electrons are emitted there. All these electrons are going where? These electrons are moving to the opposite wall, and there when they strike, they will produce a glowing light. Light is glowing there, that is, fluorescence is observed. This fluorescence is coming because of the electrons which are produced from the cathode metal plate. That is only what is, we can say, electrons were discovered in this particular experiment. Who did this? This was done by Sir J.J. Thomson. So let us now discuss the characteristics of cathode rays. So when Sir J.J. Thomson discovered this, he also discovered various characteristics. First point is they originate at the cathode. Originate means they begin, they are forming. Cathode rays always originate at cathode and they will travel in a straight line. Obviously, they will be forming at cathode, rays are forming at cathode only. That is why the name is cathode rays. And they are always traveling in a straight line. They are not going here and there simply. All of them will just move in straight lines only. All the cathode rays move in straight line. How this is proved? Just by saying we will not accept. So J.J. Thomson is saying cathode rays are moving in a straight line. So first of all he will have to prove this thing. For proving this point, he did this activity. The same discharge tube was taken, cathode rays were produced. So just say cathode rays move karenge. This here you can see they are striking this metal object. One metal object was kept in between the tube, discharge tube. In between of this discharge tube, a metal object was kept. And when the cathode rays are moving there, what is happening? So when the object is placed in the path of the cathode rays, a shadow of the object falls on the wall opposite. So this means what? Shadow is forming means shadow is proving that you can say it can be formed only and only when the rays are moving in a straight line. That means something is striking that thing. Then only shadow will form. Otherwise shadow will not form. If nothing is striking this metal plate, how the shadow will come? You can see the shadow on the right side. So this shadow is coming only because the cathode rays are colliding or striking this particular metal object. So this small activity is proving that always cathode rays move in straight line. Second point, now we'll see the characteristics. They are always a stream of particles. Stream means regularly they are flowing one particle after the other, or we can say electrons are all produced in a stream. It is not happening one electron came at one time and later on after a long time second electron will come. No, not like that. It is a continuous flow of electrons that is taking place. Until the electric current will be supplied, the cathode metal plate will keep on producing electrons. Regularly the electrons will keep on producing and they will flow like a stream. Stream is a small river like structure. So like that only, like water is flowing in river continuously. Similarly, when electric current is supplied from the cathode, this metal plate will produce electrons like a stream of particles. Here also we can prove this thing. This time we have kept one light paddle wheel, and this light paddle wheel, what it will do, when the electrons are produced from air, the cathode rays that are coming, they will strike this light paddle wheel, will be struck by the cathode rays from the left side of this diagram you can see. And when they are striking, what will happen? This light paddle wheel will keep on rotating. It will start spinning because regularly one particle is striking this light paddle wheel, and because of that striking of the electrons, it is started to move here. So this you can read also. A light paddle wheel placed in the path of the cathode ray rotates. This rotation of the light paddle wheel, this will move in a circular manner. It will start rotating. So why is it happening? Because the cathode rays particles are irregularly striking. If they are not regularly striking, it will not rotate. It will only move and again stop, again move and again stop. But it is not happening. It is regularly moving until electric current is supplied to the cathode. The third property now, the particles constituting cathode rays are negatively charged. In the beginning only I told electrons are having which charge? Electrons are having negative charge. This point was proved in this particular activity, that cathode rays are negatively charged. Why we can say? Because cathode ray always bend towards the positive plate. Because they are negative charge, and negative charge will be attracted towards the positive charge. That is a rule. We can say opposite charges are attracting each other. This force of attraction is electrostatic force of attraction is there. Because cathode rays are negative charge, they will attract towards the positive charge. So this also one activity was done. In the same discharge tube experiment only, they kept two plates. One is having negative charge, another one is having positive charge. And when the cathode rays are moving in between, what will happen? The cathode rays will deflect towards this positive plate. They will change their direction. You can see all are falling downwards. Why they are falling downwards? Because of the attraction by this positive plate. Because of this, instead of moving straight, they should have gone straight only. but they are not going straight, they are moving downward. This downward movement or this change in the direction is possible because of the attraction that is given by the positive metal plate that is kept below in this discharge tube. So because of this electrostatic force is there, and we can say electrons or cathode rays are negatively charged. The last point is there now. The particles which are constituting cathode rays are all alike. Alike means same. All the particles which are present in the cathode rays are same, and indirectly we can say all the electrons are alike or same to each other, and they will not change with the gas, electrode, kind of glass, whatever substance is used in this experiment, that will always be same. What will be same? Electrons. The nature of the electrons will always remain same. This property is what we have discussed. They will always remain same whatever setup you take up in this cathode ray experiment. On the basis of the same phenomena only the television used to work. Earlier television was cathode ray tube television. The older one televisions, they were having this same phenomena. In that also fluorescence was observed. Whenever electricity was supplied from the cathode rays, light was glowing and it was coming on the TV screen, and because of that light only the television was able to display different pictures. Whatever program you are watching, that we can easily see that. So that was also based on the same concept of fluorescence, and hence it was actually what? It was cathode ray television, CRTV. So that is based on this same thing only. So Sir J.J. Thomson discovered this particular cathode rays, and ultimately he named the particles as electrons in the year 1897. Cathode rays only were named electrons by J.J. Thomson in 1897. Now here is theoretical part. You have to just learn this. What is the charge and mass? The charge of the electron. The charge of the electron is negative charge. We always just now already we have told you the charge is negative charge, and we can say the unit. Now we can also write 1 electron is equal to -1 unit, means its charge can be written as -1. Negative charge is there, so minus value will come. What about the mass? This you will have to learn only. The mass of 1 electron is equal to 1 by 1840 of hydrogen atom. Whatever is the mass of hydrogen atom, if you divide the mass of hydrogen atom by what number? By 1840. Hydrogen atom mass divided by 1840. So this is equal to what? This is equal to the mass of electron. So just a minute, I will show in the book separately. They have given here, it is mentioned here, all the three are mentioned. So electron, here you can read and learn from here. Charge is -1, mass is 1/1840 of hydrogen atom. So that is all we can say. Mass is very very small, charge is -1. Next one now that will come about the subatomic particle is the proton. This will be discussing in the upcoming video. So today we have seen how the electrons were discovered, the process of fluorescence that is observed in this meantime, and then how Sir J.J. Thomson, the person who discovered electrons, also gave the various characteristics by various activities. So that is all for today's video. We'll continue the next topic in the next videos. Thank you.